get to the agenda of why everybody is on this call, is to be able to understand how can cloud security transform your business and how CCSP knowledge can help you with that transformation. We want to understand some basics before we get deep into what CCSP is. And one of them, which is closely related to cloud, is understanding the shared responsibility model. So we'll work and review that. Then we would talk about a few things that are different between cloud and on-premises and what are the core security challenges. We would dive into the 6 security domains that CCSP is divided into. We'll understand some critical cloud security challenges. We will share today some actionable steps for you to go and implement in your cloud security journey. And these actionable steps are for basic users who are just starting in exploring cloud and maybe using for personal use, to security architects as well as security practitioners that are operating in those larger business or organizations where cloud security is a key challenge. We'll also do a quick case study on how Netflix using AWS transformed their operations and how cloud security is a key cornerstone within that story. We'll also do some quick knowledge check for you to understand how we've been doing in the session. And then I'll also share with you a general 90-day implementation roadmap if you are working or associated with an organization that is currently doing cloud migration or leveraging cloud for its core critical services. These are very tangible little nuggets of information that you can use if you are associated with cloud in any form today. And then I'll wrap it up with doing some cloud security best practices that as practitioners we should know and understand. So diving right into what cloud security transformation with CCSP can help. We all know that organizations are rapidly adopting cloud technologies today, but that doesn't come without risk. And major risks are around misconfiguration, API vulnerabilities, and compliance gap that threaten the overall success of a cloud transformation. This is where having the knowledge of CCSP certificate provides you the comprehensive framework that you can rely on to build a resilient, compliant, and a security program. We've seen in the past that organizations are prone to data breach. In fact, the latest report from IBM from 2023 said the average cost of a breach now is $4.88 million. So these are not cheap. We've also seen that 95% of cloud breaches are due to customer misconfiguration. In addition, coupled with this, there are about 83% of global organizations that are using not just one cloud, but multiple clouds. And cloud can be any SaaS service that they're using, the likes of Salesforce, or it could be a public cloud service like AWS or Azure or Google for that matter. Now, what you would learn in this session today is how mastering the 6 CCSP domains help you with real world problem solving. So I've created a couple of examples that tie some of those domains knowledge into examples that are applicable in real world. We would also understand how implementing these controls at an enterprise level work with the security architecture. We would also understand how building automated security operation and incident response helps, as well as you can navigate compliance requirement across multiple frameworks having the knowledge of CCSP. In addition, you would get to advance your career with industry recognized certification because CCSP is held as the highest security certificate specific to cloud. All right. So understanding the cornerstone of cloud and cloud security is shared responsibility model. So what do we have as the basic concept? In cloud, for example, if you're using AWS, securing AWS, which means AWS secures the cloud infrastructure. You can see the word of there. That means security of the cloud infrastructure is the responsibility of the provider. In this case is AWS. Customer secures in the cloud, which means anything you implement in the cloud, be it compute resources, be it storage, be it a SaaS service, whatever the customer uses is the responsibility of theirs to secure. So in this case, data application and access management, a portion of it, depending on the type of cloud you're using, will be the customer responsibility or the provider responsibility. But a general rule of thumb is if you're using infrastructure as a service, you would have as a consumer more responsibility. And if you're using software as a service, as a consumer of that service, you would have less responsibility. And the cloud provider or whoever is providing you that service will have more responsibility if it is a software as a service. Now, cloud providers, what do they provide? They essentially provide you with the core physical security. So they would help you secure the hardware, the infrastructure, the data center. They would help you with, or they would provide network infrastructure. They would do some form of underlying hardware patching, and they would provide you in the form of SLA service availability. So when you use Google Dropbox uh, or Google services, Gmail, for example, they provide you with an SLA and they take care of Gmail being available or their storage being available or Google Drive being available for you to use at your own will. Now, what are the shared responsibilities that come here? Patch management. If you are hosting your own compute resources, let's say I'm running a virtual machine on cloud, the patching of that machine would be my responsibility, but it's a virtual machine that runs on a hardware. That hardware then becomes the cloud provider responsibility. So you can see that we are sharing responsibility. I'm doing a portion of my work, the cloud provider is doing their work. Now, an important aspect here to understand is incident response also becomes shared responsibility. Now, if there's an incident that's on my end, I may require to implement certain controls and manage it, but I can also engage a cloud provider to help me with that, and vice versa. Now, what are some of the core responsibilities that are driven and assigned to the customer and solely their responsibility? Data encryption. So, one thing that we say in CCSP is data is always the responsibility of the customer. You need to ensure that it is secure and has appropriate security measures implemented for its security. So data encryption is a key mechanism for say ensuring security of data, and that's always customers' responsibility. IAM in certain conditions can be fully customer responsibility, or in certain cases, a provider may be responsible, but only to provide you with the capability of doing identity and access management. So, for example, let's say Gmail. Gmail provides you the capability to put in your username and password, but managing that username and password is your responsibility. If you decide to share your Gmail username and password with everyone, Gmail can't protect you, right? So that's why they say rotate your password, make it strong. Now use passkeys or something else. Network traffic protection is something that customer has to do. And then operational system updates. This would depend on what kind of model you have, but is your can be a customer responsibility. Now let's look at a real world example for Capital One breach. I'm sure a lot of you might have heard of this banking financial service organization in US that got breached in 2019. And a lot of the blame game happened, and they tried to say it was AWS that was responsible. But let's dive into what actually happened here. So there was a misconfiguration on AWS Web Access Firewall that allowed attackers to access 100 million plus customer records. And they got fined by the US judiciary for this as well. And the root cause was that it was an overly privileged IAM role that clubbed with the server side request forgery vulnerability. And as a result of this failure, they had improper IAM configuration and application security, the two core failures in this case, which resulted in a 190 million fine and settlement. It wasn't cheap. But if you look at it in a nutshell, what happened was they had improper configuration, misconfiguration for IAM, and application security had vulnerabilities in it. So what I have is at the lower section, I've shown a sample policy of how a security policy in an S3 bucket on AWS looks like, right? So you can force some of these policies to ensure that you're protected against either server-side request forgery, or you can use better configuration management and ensure that your identities that are accessing your resources in cloud are only coming through authorized users. All right. So diving into what the difference between the risks that we see in cloud versus what are the on-premises risks. So on-premises risks are, again, we've been working on them for a very long time. So we understand physical security, legacy or outdated system have challenges. There are a lot of manual processes, the scalability challenges. Imagine 10 years ago, if you wanted to ask for a machine or a server to do some form of testing, it was very painful. It took a lot of trouble, processes to get one approved for you to work. And disaster recovery was complex. You had to know where your backups were, what needed to be recovered, depending on what kind of backup recovery the organization had. You could have hot site, cold standby sites, and whatnot, right? So it the on-premises risks are there. But with the advent of cloud, some of these things got solved, like disaster recovery. You have a concept called regions in both AWS Azure, right? They provide you with the capability of doing disaster recovery, and the provider, in fact, does a lot of that for you. So if they face issues with one of their data centers where your machines are hosted, they would move your workloads or your resources without you knowing of it, right? So, as an example, Gmail, we all know all infrastructure are prone to failures. So my assumption is, would also fail. But they've got so much redundancy and capabilities baked in that we don't see any failures. But when we see them, they're of course, in the news. But usually these big providers are very good at it in terms of managing these failures. Now, but then cloud, if it's not having the same risk as on-prem, it has its own set of challenges and risks. And what are they? That the shared infrastructure is a risk. From a consumer point of view, if I'm putting my resource, my intellectual property, my resources that provide my customer services with someone who may be my direct competitor, I would be scared to put information there because it may leak. So multi-tenancy is a concern. API vulnerabilities in the management interface. Now, because we've exposed a lot of our systems outside, an exposure in the API vulnerability has a bigger impact. So that's a challenge. Configuration drift. With the advent of DevSecOps and a lot of these other things, we are deploying faster, but there's always a risk that some changes can make our configuration move from one state to the other, and it could lead to an exposure. Vendor lock-in and data location are also key challenges that we need to solve for. Now, there are some shared risk domains as well. Insider threat, again, it's applicable to your on-premises, your cloud as well, because a cloud provider may also suffer from insider threat. Advanced persistent threats, sophisticated attacks, we see DDoS and a lot of these things happening to both customers on premises, in cloud, to cloud providers everywhere. We see or we hear a lot of news from Akamai and some other providers saying, hey, we've defended against this big DDoS. So they're all seeing it, there are controls in place, but these are risks that we are prone to. Social engineering and compliance violations are other key risks. So when we've got so many risks, what's the advantage of then using cloud? There has to be something why we are using this, right? So the key advantages that organization look for when they're doing a transformation, especially adopting cloud, is economies of scale, right? So the cloud provider gives you a lot of resources for cheaper because they can provision a lot more and divide it up and bundle it to different customers, right? So they use economies of scale, buy in bulk, share little, and then sell it to customers, and the customer also get the benefit. Rapid updates. You can see that cloud is moving really fast. In the era of Gen AI and ML, you need a lot of computing, and a cloud provides you that capability. And there's global reach. If I wanted to create resources in US right now, sitting from Australia, in AWS or Azure, I can spin one up in less than a minute, right? So there's global reach and distribution. And these are the things that are pulling customers towards cloud. Now, there are cloud specific risks that I told you. What I'm going to share in this slide is very tangible examples of where we've seen something go wrong and what happens. So basic that we shared around shared responsibility, it can also lead to confusion. So as in the case of Capital One, they were not sure who's supposed to configure what, right? So as an example, you can see in 2018, the S3 bucket leak, in 2020, Twilio API breach. All of these were related to either lack of understanding of shared responsibility with the consumer saying, hey, I'm using AWS, they should secure their. No, but the challenge here is that AWS creates, or any cloud provider will create controls for you to implement them as per your requirement, right? So it's as simple as the bank will give you capability to log into your application from your phone and share or send money to anybody. Now, if you decide to share that username and password with anybody that you meet on the street, then who's responsible? You are responsible because the bank gave you a method to secure your account, but you decided to then share your knowledge with everybody, right? So you can't blame the bank. Why is money missing in my account when there are 10, 15 different people able to log into your bank and make transactions, right? So what are the implications here? As a beginner, having the good understanding or core understanding of what shared responsibility is really important. As an intermediate user or an advanced professional with cloud security knowledge, you would want to get your knowledge around some CSPM tools or understand how the overall architecture and governance model work in cloud, right? Same way for on-premises, the risk is around physical security vulnerabilities, unpatched legacy system. We often see this coming up back to back, but as a CCSP aspirant, what you would want to know is what's the significance of patching system? As an intermediate, what can I do if there are vulnerabilities within my environment? Automated backups. Advanced users or practitioners would want to know how to integrate hybrid monitoring. Can I monitor my on-premises cloud? How do I know how many vulnerabilities do I have? What kind of patching frequencies do I need? And then again, there are shared risk around data breaches and insider threats. And then knowing what your basic controls are, having same solution and having a hybrid design is what gives you the edge in these cases. Now, coming back to CCSP, how this is designed to help you understand those few risks that we've talked about. There are a lot more risk in cloud. We've not covered all of them. But what CCSP and ISC Square does is it does a great job at chopping down the entire syllabus into understandable concepts and then breaks them down into key domains. So, for example, domain one is around understanding basic cloud concepts, where you understand majority of how architecture and designs, deployment models, reference architecture, understanding the basic business models as well as risk management. So that's what domain one knowledge would give you. Now, domain two is more centered around data. You understand what a data lifecycle is. How do you classify data? What are the encryption mechanism? How do you manage data at scale when it is moving within your organization and outside with controls like DLP, DRM, etc. Domain three is again around infrastructure protection. A lot of us who've got basic or previous experience working with on-premises environments tend to do really well, but this does also come with a lot of core concepts around containers, compute, and virtualization. That may be something that is new for few of our uh, peers who are venturing into CCSP. And then we've got application security. This is a pillar domain, and I've seen a lot of my peers when I was studying for this, and over the last couple of years, people struggle with this domain because of its broad breadth. But this is where some of the key actual day-to-day usage can translate into. It does cover aspects like OWASP top 10. How do you mitigate a lot of those basic application security challenges? It introduces identity and access management as well as serverless security. A core one here is how do you ensure that security is doing secure by design, shifting left, and then doing the security across the entire software development lifecycle, which is the SDLC integration. And then you've got operations as well. I know a lot of us who work in SOC or have experience there, they would enjoy this domain a lot. It talks about how do you operationalize and excel in operations around cloud security. So, incident response, logging and monitoring, vulnerability management, change management, a lot of that is under this domain. And then the last one is around legal and compliance. You understand what are the different regulatory challenges someone faces when they are operating in cloud. What are some of the local regulatory requirements versus um, operating in different regions that you may be exposed to, and then what should one do when they come across these requirements. We also in this domain talk about audit process, contracts. How do you ensure that the cloud provider is giving you what they have initially uh, told you or promised you? How do I ensure that promises are kept? It's through SLAs and contracts, right? So those six pillars or domains that I spoke about, what do they actually give you as a real user, right? So when I talk about domain one, I said architecture and design. As an example, if you see, it will help you align what kind of models does your business need. So for example, if I am a government entity, or I am someone who's working for a government entity. Should I go and start creating stuff in AWS? Not sure. But having the knowledge of this domain will guide you. Is that a good design for you or not? Right. For example, Netflix has a hybrid design model where they use AWS and GCP, and they've also got some level of infrastructure as a service and PaaS selection. Now, all of these combined together solve business challenges for Netflix. As a beginner, you would want to get yourself exposed to, for example, in AWS tooling like AWS config. Config tells you what the state of your environment in AWS is. As an advanced user or a practitioner, you would want to know how AWS organization and Azure policies work because they are tools that define the governance within the cloud environment and help you adapt, right? Same way with data security. The main principle is understanding what level of protection does my data need, and then is encryption good for it? If so, what kind of encryption, right? And then how does data move inside my environment and all. So few examples are Dropbox basic encryption, as well as you've got Vault of zero knowledge. These are based on the concept of homomorphic encryption, where you don't decrypt the data um, and still be able to process it. So, understanding some of these things. Platform and infrastructure security, again, understanding what networks and containers are, how do they interact, what kind of micro-segmentation can you do. Micro-segmentation, again, is a core pillar for zero trust. That's also something that's part of the ISC squared CCSP syllabus. So having that knowledge not only helps you uh, get better and be able to pass the exam, but also translate that into something you do day in, day out if you are operating in a cloud environment. Having the understanding of basics like VPC, Kubernetes for RBAC and other stuff. And then application security, DevSecOps is a very key concept here, understanding how application development works. How do I integrate my security? Example, code reviews. There are code pipelines. You've got scanning in place that helps you with um, embedding security during the software development. And then the last two domains, the cloud operation, this is where you've got automated SIM and SOAR uh, for your incident response. You I'm sure some of you would have had experience working with Splunk and a lot of different tooling. There are tooling that is natively to cloud as well. For example, in Azure, you've got Sentinel. In AWS, you have GuardDuty, Security Lake, Security Hub, a lot of these tools. And then the last one, which is a tricky one because it covers a lot of different governance models around compliance and how regulatory requirements change between Europe, US, and different parts of the world. So it gives you a taste of how cross-border transactions of data and what's required and what can happen if you try and uh, fall into those regulatory tussles. How should you decide how to move forward? All of that is covered as part of the legal and compliance risk. Now, we've talked a lot about, okay, what does CCSP cover? But then what are the critical security challenges today in the real world implementation, right? So if I was to uh, go into an environment today which started off just using cloud as a new adoption and they're looking for transformation to be supported with this cloud journey. Some of the key risk in those environments would be around identity and access management, right? So the challenge is complex cloud identity federation. We've spoken about how sharing your credentials can cause a lot of harm. So that's always a challenge with IAM. or identity and access management, especially in cloud. Knowing what to protect, how to protect is important. Then, configuration management. We've already seen an example of misconfiguration causing millions of dollars of loss. So configuration management is important. Knowing that your organization use some form of automation and infrastructure as a code is important. Ensuring that whatever is using infrastructure as a code is also not drifting. So no manual changes are being done to bypass that is important. Equally important is visibility and monitoring. You can't protect what you can't see. So having good monitoring and visibility is important in cloud. And then uh, one of the core pillars is data protection, especially in cloud, knowing how I protect my data, what keys or encryption method should I use, where can I rely on the provider versus where should I put my own controls is really important. And these are challenges that major organization, be it Fortune 100 or someone who's newly adopting cloud, all of them have in common. And knowing and understanding how you can solve these challenges make you a great asset for an organization. And this is what exactly by doing CCSP, you would know, understand, and then that gives you the capability to be in front of any executive board managers and tell them that you can solve that challenge for them because you know how to approach it. Now, what's the success metric here? Having a good security posture, knowing how compliant your organization infrastructure, especially in cloud, is really important. Operational efficiency is what organization look for. And then the key goal for any organization is to not eliminate the risk, but reduce the risk to a level that's acceptable to the organization, right? So that's where you can help the organization put just enough controls that make sure that the organization risk is within the appetite and making those controls more effective for the organization. Now, what are the actionable steps that someone who's looking to do cloud security would want to do today? As a beginner, if you had no clue what cloud security would be, I would say pick up identity and access management and then try and look for actions like multi-factor authentication. In cloud, there are two primary areas of focus within identity and access management. I'm not sure if few of you have access or have played around with consoles of AWS or Azure. The direct access when you try and log in for the first time is something called management access to the account, right? And that is where your root or core credentials live. We always recommend as cloud security practitioner that the main core control, which is through that management account, needs to be locked. And because it has God level permission within your cloud environment, we make sure that it has multi-factor authentication on it. So this is where knowing that your console access needs to be limited, make sure you use a lot of automation and infrastructure as a code to use and do your daily tasks. But then when you need admin access, it always needs to be protected with a multi-factor authentication. The other thing that we would also want to do is ensure any of your storage is not directly exposed to the internet. So someone can't hit the API directly and then just transfer of information, right? So that is where exposing or making sure that you're not exposing some of your um, hard-earned organization secrets and data is really important. You would learn about this in domain 2. And then you would have intermediary controls that are more or less like strategic in nature. For example, CSPM, which are cloud security posture management tool that monitor and fix misconfiguration. These are tools like AWS Config that are native, or you could get a third-party tool as well, right? So these are things that are add-on, but day one, you would want to secure your IAM, secure your environment, as well as make sure your storage is not really exposed. Then domain 5, another aspect would be how do I monitor my security events? Logging monitoring, I could use a third-party software or native, doesn't really matter as long as you're doing it and it's fine-tuned. In the advanced section is where a lot of governance aspects are. So if you are aspiring to be an enterprise security architect or a cloud security solution architect or a specialist, having core knowledge from domain 1 and domain 5 is really important. You want to know how should an organization structure their cloud resources so that it provides you a level of control. A simple example would be I should have segregation between my production and non-production environments. I should have my production environment maybe uh, isolated and not open to everybody within the organization. Those are governance control that we can apply, right? In addition, I could have automated response and monitoring within the environment as well. So these are all things that you would get exposed to when you go and deep dive into a CCSP domain and dwell into the full syllabus. Now, let's move into the quick case study that I had promised to showcase. There are multiple ways that you can use a framework. There is a framework from CSA, Cloud Security Alliance, but cloud providers themselves also have something called well-architected framework. What a well-architected framework is, cloud provider giving you guidance around how they envision that you should operate in their environment. Both AWS and Azure have their versions of well-architected framework, and the well-architected framework not only covers key aspects like governance, financial cost optimization, but they also cover specifically security. So the AWS well-architected framework, the security pillar will actually tell you that your environment should have a separate account where you should log all your security logs. And that logging account should only be accessed by someone from your security team. So we all know what Netflix does. It gives us great content for binge watching on Saturdays and Sundays. And it also serves global customers. How many? 230 plus million subscribers globally with an impressive 99.99 availability requirement. Um, I've been using Netflix for past maybe 8 years, and I've only seen it be offline for a couple of minutes, maybe twice in that 8 years, which is really impressive. But as I said, everything in technology breaks and is prone to disruption. So Netflix, how is it solving the challenge of operating in cloud and how is it doing securely is the case study for today, right? So before we get started, we always need to understand as security practitioner, and this is a tip for someone who's looking to go and grow into a cloud security architect or an enterprise security architect, is to understand what is the goal of the business, right? We all need to understand that security is an enabler for the business. So if an organization wants to do something, they look at security as an assistant that will help their business grow. So unless I can understand what the business is trying to do, securing it doesn't make sense. So for example, let's say my business is to share public information from my forum. Now, if I make that forum very difficult to reach, and put layers and layers of control, rather than helping the business, I will impact the business because it's public information. We want to scale and give it to as many people as possible. But security is becoming a blocker, right? So that's no knowledge of business causing a bigger impact than not having any security, right? So as a result, if you are someone who's looking to be into that enterprise security architecture role or a security solution architect role, or in general do want to do better as a security practitioner, start learning the business requirement. So in this case, from the first instance itself, we understand that Netflix wants to serve a lot of different customers in millions and global with a very high uptime. So that means they can't afford to be down for a very long time where customers are not able to access their service. They want to stream billions plus hours of content monthly. They want to be compliant with GDPR, CPPA, and regional regulatory requirement because they are a global organization. They're exposed to a lot of different regulations, right? And then they also want to scale across 190 plus countries dynamically. That means a content that's available in India is also available in Australia, is also available in US and any other part of the world, right? So that's where what are the initial security challenges that we drive from this business requirement. So what our understanding would be that they would want to understand what shared responsibility model is. Now Netflix, when it uses AWS, can't go and say, hey, we'll send you 500 guards to protect the 50 data centers that Azure AWS has across the globe. No, that's not a job that uh, Netflix should be doing, right? What they should be doing is they should be understanding the shared responsibility model and understanding what is their portion of the control that they need to do. So when they build an application in AWS, they need to ensure that they configure authentication and authorization for that application, right? But protecting data centers is not something Netflix should be doing on behalf of AWS. It is the AWS responsibility. What's the next thing that you would need to do? As an intermediate security practitioner, you need to understand how do I consistently apply some of the security policies that I've created, because Netflix to serve so many customers will have a very big, huge cloud environment. I can't manually go and make changes or approve changes or scale up if I'm going to do everything manually. So we need to ensure that there are consistent policies in place and they're scalable. And the last one is the important one. You need to help build automation and compliance that can scale to the same level as the organization infrastructure is, right? Now, how does this align with what you would learn in CCSP, right? So CCSP domain one, the architecture one, does give you a hint. So it doesn't deep dive into, but will generally make you aware of frameworks like AWS well architected framework, especially the security pillar. This is something that I shared a couple of minutes ago. Domain 6 will help you understand what those GDPR or different regulatory requirements are, and should the organization operate in those environments? If so, what are the controls that are required for the organization? So, in essence, having a good understanding maybe in AWS around organization, if you are using Azure tenants and how subscriptions work would be really important. Having configuration, AWS config in place, and maybe a cloud service like Prisma. So that's what stage one, which is the infrastructure visibility and governance provides. Now, what stage two? This is where we deep dive into data protection and infrastructure security. something we cover in domain 2 and domain 3. Now, Netflix, when it hosts so many different regions and serves so many customers, they obviously want to store data, right? They want to store those movies, net series, and a lot of different other type of content that they show. In fact, they've got around 15 plus petabytes of content. And not to forget that they also take credit cards, different methods for payment, right? They've got your personal details around your email ID, your full name, and other types of personal information for their customers, right? So all of that needs protection. So they need to, in tandem, secure the services that run on virtual machine or cloud to secure that entire infrastructure and support the different streaming service. In addition, you would want to implement a zero trust architecture and also encrypt all data in transit and at rest. So these are technical requirements that we can derive from the business requirement. Now, how is security risk addressed here? So if remember we spoke about exposed S3 buckets leaking data. So one of the basic steps that we spoke about previously was to in fact configure and ensure that S3 buckets are secure and not publicly exposed. So nobody can hit a Netflix S3 bucket hosted on AWS and get a movie directly from there. They all have to go through the Netflix app, authenticate, and get that data. Now, that is also a form of digital right management. So, I'm not sure if you've tried this, but whenever I travel overseas, I make sure that I log into my Netflix account and download a few movies that I can watch in transit. Now, what happens is that the Netflix platform has something called DRM, and uh, what that would do is that would ensure that even though I'm offline, not connected on the internet, the file that I have saved locally is only accessible via the Netflix application and not something else. So, thus, implementing a control that allows you to ensure that your information, whatever you expose outside of the organization, is controlled and not exposed to anybody. I'll just pause here for a second. There's a question that came from one of the attendees is, what is the tool we use to scan misconfiguration of S3 bucket? That's a great question. There are multiple tools available to do this scanning. There are cloud security posture management tools that help you primarily with this. In AWS, if you look at it specifically, AWS configuration or AWS config as we know it is a tool that would help you understand if your configuration drift is there, and especially if there is a misconfigured S3 bucket. In addition, you can also have policies operated or applied at the account level that actually prevent a creation of a misconfigured S3 bucket as well. So those policies are called SCP policies specifically in AWS. If you implement that, if you try and then create an S3 bucket that is publicly accessible, it would deny that action to the user because of the policy. So there's a governance or a preventative control, which is SCP, and there is also a detective control, which is via the AWS config. You can also have different automation and workflow trigger in AWS config that allow you to convert that into a detective and a preventative control. That means it would run an automation script and maybe delete that S3 specific bucket or delete the misconfiguration in your environment. So in case you do not have AWS organization, then SCPs in fact can't be applied. but you can then also still have AWS IAM and a policy there that can maybe prevent such kind of configuration. But then in that case, I would be more relying on the detective control around AWS config natively. Or you could be using a third party CSPM tool as well that could do the same monitoring for you. All right, moving on. In terms of the second stage of CCSP implementation, what you would want to understand from the domain 2 and domain 3 would be, how do I manage my keys? What kind of key management do I need? Where do I encrypt my data? And how do I ensure that data doesn't leave my environment? So DLP, AWS Macie is one of the tools that helps you do that. In domain 3, we've got VPC isolation, so the micro-segmentation or the zero trust strategy that we have got. We've got application security via WAF, network load balancers, and other things. One cool thing that uh, is there in Netflix is they create a lot of these different internal softwares like Security Monkey. There is one more that I'm not remembering. But what these softwares are designed to do is induce failures in their environment. That ensures that they're always testing their environment. We are trying to break it. And if a service breaks, we are one of their internal tools. That means there is some misconfiguration in their environment. So they would deliberately go and shut down a working production server and see if there is a software failure or some failure which is either seen by one of their customers or someone else. And what that does is makes them conscious when they're developing tools and implementing something in the environment, that they make sure that it's to the standard and a failure in one place in the environment does not break their application or service that they're providing to the customer. So as a result, they're able to maintain that 99.9% SLA. It's a great case study if you wanted to know about Security Monkey, and there's one more that Gorilla or something that they have. They do go to the extent of deleting even their regions in AWS to test if they can fail over to a different region and how fast and without any impact to the customer. Uh, Then, as a CCSP, knowing and understanding application security and DevSecOps part of domain 4 is really critical because everybody these days is trying to ship fast. Within a few days, you see a lot of different features and changes in your Netflix app, the kind of content they show, the UI. A lot of this thing changes. Sometimes they would make changes to make it faster or load stuff in a different way, right? So all of that happens because they are doing a lot of deployment, internal process updates, and a lot of these things, which requires huge amount of compute and microservices to support, right? So that's where challenges around secure code practice, right? You're developing something always, so you need to do it securely. Now, on top of that, you would also want to know the infrastructure where I'm developing, the containers. They also need to be able to be robust enough that they're not exposed or vulnerable in the environment. So having those vulnerability management, scanning done at every deployment. I'm sure a lot of you would be aware who've been integrated in SDLC that we enforce SaaS tools, code scanning, vulnerability scanning, image scanning. There's also a concept called golden image. So what organization do is rather than scanning all of their machines every time, they would build one robust hardened machine that's the basis of all their deployments for that month, while there is still ongoing scanning that happens with those machines, but you're starting from a good hardened machine to start off with, right? So that's also a cornerstone for your container vulnerability management. Yes. Um, Advanced is runtime application protection. These are tools that fall into the category of RASP, and they perform real-time monitoring on your critical workloads. So domain 4 would give you an opportunity to understand SaaS, DaaS, CI/CD pipeline, Docker scanning, API security, OAuth, and a lot of other things, right? Finally, stage 4 is where you advance into the operation and monitoring stage. So this is part of domain 5. That's where you would layer your all environment with good monitoring, understanding your mean time to discovery and mean time to remediation or recovery. Chaos engineering is the term that I was looking for, that was made popular by Netflix because they induce chaos in their environment at will to trust and make sure that there is resiliency. Abhi, you've got one more question. Is IAST and RAS concept similar? They are similar with a very small difference that you would get to know in when you learn more about CCSP. But that's something that's covered as part of, I think, domain 4. In terms of domain 5, what we've also got is introduction to topics like DDoS attack prevention, supply chain attacks, how do you protect yourself against nation state attacks, monitoring, as I said, same solution, CloudTrail, GuardDuty, Chaos Monkey, all of that would help you. So in essence, we've seen that how some of these different controls, starting from domain 1 to domain 5, covered with different strategic stages, layered together, help an organization like Netflix understand, implement, and continuously monitor their environment so that they can serve their customers. Now, this is a funny little architecture that I have covered, which talks about how, as they progress in their journey, how maturity in different stages has helped Netflix get the desired result. You can see that not everything starts from the same point, but they're all delivering different results. Design and architecture and engineering start pretty up, whereas some of the MTD and compliance, the automation would catch up later on in the organization. So Netflix AWS architecture is designed to handle large amount of data, have huge infrastructure protected with zero trust, as well as provide 24 by 7 monitoring. All right. So Asif has a question. Will the course cover the technical solutions you're referring to these problems? Well, the one that I delivered touches upon these, but we would limit the amount of deep dive we do. However, I try and generally make sure that I give you tangible examples that you can take forward and implement or either test. But again, this is a course for CCSP that's designed for you to understand real challenges as well as the entire course material, because passing the exam is also something we focus on. And ensuring that you are certified gives you that capability and the confidence. What security controls do we have specifically for advanced level cyber attacks like supply chain, example, business email compromise? So this is a very broad question, not just limited to cloud. Supply chain attacks are primarily uh, applicable in any environment that you operate in, but understanding and having good understanding of your suppliers and ensuring that you monitor contracts and SLAs with them is a key here. So having third party risk management or GRC function is good, but the cornerstone VAMC of GRC and TPCRM is those contracts and SLAs. So you would want to understand if a provider is has SOC 2 type 2 compliance, what kind of controls do they have, are they in line with the controls you're expecting? And if not, then you shouldn't be the one doing business with them, or maybe they are not the provider for your organization, right? So they are layering, and when we go through the CCSP, uh, we would talk about some of these controls. Going into some knowledge check, and I've just created very basic questions around what you would have. So, shared responsibility model. Please punch in your questions in the chat if you would like to. So, the first question we have is, a company experiences a data breach due to misconfiguration of S3 bucket permission. Who is primarily responsible here? Would it be AWS as they provided the service? Would it be the customer as they configure permission? Or would it be both as it's a shared responsibility model? So I'll just wait here for a minute and then see the answers roll in. And of course, the answer is B. So the customer is responsible for configuring the permissions of S3. Cloud provider here is responsible for handling the underlying infrastructure and also building the capability that allows for this permission to be configured, right? So if you look at it from the aspect that while using the banking app, it's the bank who needs to give you the capability to put in your username and password and then authenticate. But configuring a strong password and not sharing it with anybody is uh, your control or something that you need to do, your responsibility, right? So good job to everybody who's answered B. Uh, Going to the next question, incident response. This is coming from domain 5. What is the most effective automated response to detect unusual API calls from compromised credentials? How do I know if there are unusual API calls from compromised credentials? So that means the credentials are already leaked and I have to detect unusual API calls. Increase logging verbosity, automatically disable the compromise account, and or the third one is send email notification. We are looking for the most effective automated response to compromised credentials. So when you know the credential is compromised, there's no point having that credential in your environment, right? So I would want to automatically disable the compromised account. So a tool like SOAR or security orchestration and automated response will help you disable this. And as I said, in AWS, guard duty, sorry, AWS config is a tool that can help you with this capability. In Azure, you could have a SOAR tool or maybe an extended service from Sentinel might be allowing you. So good job everyone who's answered answer as B. Question number 3 and the last question for today is data protection. Which approach provides the best protection for sensitive data in a multi-cloud environment? So how do you protect sensitive data in multi-cloud environment? And best is what we are looking for. Native cloud provider encryption only, customer managed keys with CASB solution, and then application level encryption only. B is right. Customer managed keys ensure that you maintain control over encryption, while CASB provides consistent governance across multiple clouds. So the real key in this was protection of sensitive data in a multi-cloud environment. So having native cloud provider encryption is not good enough for sensitive data. And because you're doing it in a multi-cloud environment, application level encryption may not scale. So CASB provides visibility as well as it acts as a proxy in the middle. So good job to everybody who answered B. While it wasn't a conscious effort to have everything as the correct answer as B, but it turned out to be that way. But excellent work. Excellent to whoever has managed to get all three correct. And I can see a few of you have got those three correct. So now, as I said, uh, in this session, we also wanted to give you some tangible things that you could do if you are new to cloud security or if you are in an organization that's going through this. So, in the first 30 days, from an organization perspective, what would I want to do if I'm doing a transformation to cloud and I want to do it securely? The focus would be around doing identity and access management and some portion of governance here. So really using the knowledge of domain 1 and domain 6 is key. So enable those MFAs on your admin account. Ensure that your architecture is using organization and Azure management groups. Deploy central logging, enable those basic logging, and put those basic security policies in place, right? So that's what you would want to do when you start off. But in the next 30 days, you would want to layer your controls and make sure that the infrastructure is appropriate to bring in those uh, in workloads into cloud. That means you layer your VPCs, micro-segmentation strategy, all of that needs to be very clearly defined, as well as you also build your data security capabilities, like what kind of encryption would I have? Do I just use the the provider provided configuration, or do I get my own keys? And then use the detective controls around config and Azure policy rules, implement network segmentation, and do backups. These are really important and a key strategy for mitigating some risk like ransomware in the environment, right? Also help you with some of business continuity and disaster recovery planning. And then with the next 30 days, you can do optimization around SIM monitoring. Make sure you're getting logging and that logging is refined to your environment. SIM solutions are sometimes notorious for false positive. So ensuring that you've got your configuration right is important. Automated alerting, incident response playbooks, know what needs to be done when you detect an incident and how you want to mitigate it, and then establish some form of ongoing compliance and reporting, right? So having these three different sections covered over the first 90 days sets you up really well to have good compliance, good overall outcome and achievement, and a risk reduction in the environment, right? So that's where I want to just wrap this up with some good cloud security best practices, right? So some of the proven strategies that we've known is can't really focus enough on just knowing what your architecture design is, baking those defense in depth, zero trust, least privilege, fail secure models. So make sure that you've got deny by default, right? So not permitted by default, but denied by default. Having good development cycles. So integrating DevSecOps into your environment, shifting left, engage early in the SDLC process, have automation like SaaS DAST in your CI/CD and doing container security, and then doing continuous monitoring, real-time alerting and behavior analytics is important, but this is more of advanced solution. Compliance automation is also something that a lot of organizations look forward to purely because of the immutable nature that uh, cloud provides. And then human aspect and factor is always something to consider in cybersecurity in general. So knowing that your users are trained, understand what needs to happen, the incident response plans are definitely defined. Doing access reviews periodically is still as important in cloud as in on-premises, and also doing a cultural shift around security first mindset is really important. So, as pro tips from industry expert, as I said, visibility is really important. You can't protect what you can't see, so that's important. Automate as much as possible. Automate the processes around detection, response, and compliance, and measure and improve. Security is a journey. You you would want to know where you are at, plan out your maturity models in every aspects. There's a very good uh, document from NIST around zero trust maturity. I've seen some organizations use that. AWS also has something called AWS Security Maturity Model. So that is something that if you are interested, I would highly recommend you go and look at. That maps out what are things that organizations can do to measure and improve their security posture in cloud.